All right, guys, we are going to work with geometric probability today. There's a lot of things in real life that you guys are impacted by that is structured because of probability that maybe you don't realize or recognize. Okay, we talked about in the last couple classes, you know, the speed in which you receive your food at a fast food joint is based on probability. Okay, they structure and they staff their facilities based off of probability. Okay, you guys know what a queue is? Like if I'm in a queue.
Like waiting.
A waiting line, right? Okay, so you know, if you've ever talked on the phone with somebody and like calling like a customer service or something like that, and they say, you know, the wait is X amount of minutes because there's people in front of you. Your spot is 10 in the queue or something like that, meaning that there's 9 other people in front of me that need to answer questions before they get to me. Same thing happens when you go to McDonald's. If you go in the McDonald's and you're the 4th car in line, you're the 4th position in that queue. Okay. Now McDonald's, what they're interested in doing is getting people through the line quickly, right? Because they want you to experience fast food, because they want that experience to be the reason that lures you back to getting their food, right? Not so much that it tastes good, but that fact that it was convenient and you got it quickly and you can go on to the rest of your day.
What's your favorite fast food place? What's your favorite fast food place?
I don't know.
Because they're going so fast.
So the probability that they're interested in is the likelihood that car A drives up and gets their food within 4 to 8 minutes or something like that, 5 to 10 minutes. They have some preset defined interval in which they've determined using data, collecting data and collecting information from customers that, you know, customers said and say, yeah, we're okay waiting 5 minutes. We're okay waiting 10 minutes. We're not okay waiting 13 minutes. Okay? So there's a threshold somewhere. I mean, let's say it's 4 to 8. Okay? So that we want that probability that at any time of the day you pull up and it's a 4 to 8 minute wait. We want the probability of you getting your food between 4 minutes and 8 minutes to be very, very high. We want it to be like 99.9999%. Okay? If they collect data, and you can, every once in a while you'll see people like with computers outside like a fast food restaurant or whatever, and I know this because, not that I go to fast food restaurants a lot, but in college we had to, you know, we talked about this, we discussed this, and then I ended up being kind of on the lookout for this, and you would see these, they're like CEOs, whatever, they're part of the analytics department of like McDonald's or Burger King or whatever, and they go through these restaurants and they sit and they just collect data on people coming through. Okay, so they say once they order, now how long do they have to wait until they get their food? And they clock that person and they keep doing that over and over and over and over again through several, how much data they need to collect. Maybe they do it for several days or whatever. Okay, they want that probability between 4 and 8 minutes to be very high. If you're outside that, okay, then what decisions does that allow them to make? Okay, if the probability is high between 4 and 8, okay, and that's what we want. So let's say that we go through, we collect data, and we see that it's not getting these people food until 14 minutes, 15 minutes. What is that doing to that repeat customer? They're going to do what? They're going to go somewhere else, right? And that McDonald's not loses money, right? So how does McDonald's get you to wait instead of 15 minutes down to 6 minutes? How do they get that to happen?
Fire people.
Okay, they fire people, maybe those are decisions they make, but at least in staffing, they probably put more people in there, or more people that can get the job done to where your food is out in that amount of time, right? Okay, and it allows them to make staffing decisions at certain times of the day. Okay, there probably shouldn't be 13 people working at McDonald's at 4 a.m. in the morning, right? Okay, but maybe at 6 a.m. in the morning, they maybe should have more people working there. Okay, because everybody's buying breakfast then, right? So probability allows them to make those decisions. Okay. Now, for the same reason, we don't want somebody to go order fast food and they order and they get it in 2 minutes. Now that happens a lot. Okay, if you order like one thing or something like that, maybe you get it real quick. But if I order a large meal, they don't want me to get that food Under 4 minutes. Why? Okay, so you got that aspect. Maybe that food's been sitting there for a while. But the idea, if you're running everybody through these lines within 2 to 3 minutes, and they're a large amount of meals, but the customer said, we're accepting of sitting there for 5 minutes, but you're overworking, you're getting it done in 2 minutes. Good job for you, but you probably got more people in that building than you need. And what is McDonald's doing to those people that are in that building that are working? They're paying them, okay? If the customer base is okay waiting 5 minutes and we're getting the job done in 2 minutes, we're overpaying for what the customer expects. Does that make sense? So that probability allows them to make better decisions. And understanding that probability allows them to make staffing decisions and that kind of thing, okay? There's an entire branch of mathematics that deals with solely just probability, okay? And you can get into probability with very simple questions that you could ask actually involve like probability and compass with calculus and all that kind of stuff, okay? So we're going to scratch the surface of probability. You've maybe done some probability with like pulling cards out of a deck, names out of a hat, probability that's going to rain or something like that. You've dealt with your fundamental concepts of probability in maybe Algebra 1, maybe 7th and 8th grade. We'll talk a little bit more about that kind of stuff later on, okay, after Chapter 12. But right now, you're going to find out why we talk about probability a little bit here because of the type of probability this is going to be, okay? We talk about probability as the likelihood of an event occurring, okay? Sometimes called the chance of something occurring, okay, or the chance of something happening, okay? Says it's usually written as P, capital P for probability, and then in parentheses, it's the event that we're interested in happening. So maybe it's pulling an ace out of a deck of cards. So we'd have P and then in parentheses an ace, okay? Or maybe I want to pull out a name out of the hat, so it would be P parentheses Johnny. Okay, we'll pull his name out of the hat. Okay, but that information that's in the parentheses is the outcome that we want to happen. Okay, and then we'll go through there's formulas and all that kind of stuff and relationships that allow us to then determine the value of that probability, numerical value, based on the situation that's happening. Okay. You've maybe talked about independent events, dependent events, and all that kind of stuff. Okay, if I flip a coin and roll a dice, and I ask what's the probability that I get a 1/2, what's the probability I get a heads on the coin, which would be the 1/2, and getting a 6 on the dice. Does the fact that I got a heads on the coin have any impact on what the dice shows up as? No. So those are said to be independent events. And simply all we have to do then is multiply their probabilities together. So 1/2 and 1/6 multiplied together, I get 1/12. That's the probability of that event occurring. Okay. We have dependent events. Dependent events are the idea, okay, if I give you a deck of cards and I say, pull a card out of that deck, put it in your pocket. Now pull a second card. What's the probability that second card is an ace? Doesn't it matter whether that first card was an ace or not? Okay. So those are called dependent events, and we'll talk about those. Okay. But those are maybe probabilities that you are more familiar with. Geometric probabilities, maybe not so much. Okay. Regardless, when we deal with probability, the overall concept is that the probability of an event, the numerator is the number of favorable outcomes, the number of things that you want to happen. I want a heads to show up. How many heads are there on a coin? 1. Maybe I want an odd number to show up on my dice. How many odd numbers are there on a dice? 3. Okay? So those would be my favorable outcomes. Okay? If I want to pick a face card out of a deck of cards, there's 12 face cards, so that would be the favorable number. Okay? And that would be my numerator. The number of possible outcomes, that's the number of all things that could happen. Maybe in other classes you refer to that as the sample space, which you're choosing out of. Let's say I have a bag of marbles. I have 20 red marbles and I got 30 blue marbles. When I pick a marble out, the sample space, the space that I get to choose from, all the possible outcomes would be 50 marbles, right? Does that make sense? Okay. So the sample space is your denominator. That's the number of possible outcomes that could occur. Okay. The last bullet there says that your probability is going to occur between 0 and 1. Okay? If I say that, I give you a deck of cards, let's do this. Let's roll a dice. Say I roll a dice, a normal dice, okay? 6 sides on it, and I ask you, what's the probability that a number between 1 and 6 shows up? What's that probability?
100%.
It's 100%, right? It's certain to happen. Those are the only options that could occur, right? Okay? If I ask you to roll that dice, and now I ask you what's the probability that a 12 shows up, and it's a 6-sided dice, what's that probability? 0. It cannot happen, right? It's impossible. Okay? Well, if it's not a standard dice, then maybe it does happen. But our standard dice, 1, 2, 3, 4, 5, 6. If I ask you if 12 shows up, that's not going to happen, right? If I give you a deck of cards and I ask you when you pull a card out, what's the probability that you pull a cat out? What's the probability of that? I don't think a cat snuck in there. It's not going to happen, right? It's 0. Okay? So 0% probability means it's not happening. 100% probability means it is certain to happen. It's going to happen. And the word we use is that we say it is certain. Okay? 0, yes, 0 to 1 as a decimal, or 0 to 100% as a percent is what we'll be looking at. Okay? All right, so geometric probability. Okay, this is still probability, but it's now using geometric models to solve or to express certain situations, certain types of problems. Okay? It might be that idea of waiting in line. Okay, probability, how long I'm going to have to wait for something to, some service to be provided. Okay, whether I get my food, we'll see one question here in a little bit, that I get on a train, that kind of thing. Okay? They might be probability questions that say, okay, if I'm a parachutist, okay, and I jump out of an airplane and I know I'm going to land in this field, but this field has 3 trees in it. What's the probability that I land on the ground versus the probability I land in a tree? Okay, those are geometric concepts. Okay, that would be focusing then on comparing areas eventually. Okay, so in geometry geometric probability, points on a segment or in a region of a plane represent outcomes. Okay, so points on your segment could be representative of outcomes. And when we talk about the geometric probability of an event in a ratio that involves geometric measures such as length or area, the favorable outcomes, if we're talking about length, would be portions of a segment that your point is going to come off of, divided by the entire length of the segment that your favorable outcomes came from. If we're talking about areas, then let's say we're talking about the parachutist jumping out of the airplane, the total area of the field they're going to land in would be your possible outcomes. And maybe if I want to find out the probability of landing in a tree, then the area of the trees would be my favorable outcome. It's not that it's a favorable thing to land in a tree, but it would be matching up to the event. Okay, so those are things that we're kind of discuss as we go through some examples. Okay, so here is the rule that we talk about, or the concept, I guess, that we discuss when we talk about kind of waiting in a line. Okay, it says point S on segment AD is chosen at random. So you got this S somewhere. Okay, so this point S is somewhere on this line. And I want to say, what is the probability that it landed when I pulled it off, it was in between B and C, right? Okay. So the probability that S is on BC is the ratio of the length of BC divided by the length of AD. Okay. So BC, I want my point S to be on B. I want to know what that probability is. What is it? What's the probability? What is the favorable outcome of it being on BC? So it's BC's length, right? Okay. And then the total number of outcomes says it could have been anywhere on AD. Well, AD's length then could be my denominator. If I take BC divided by AD, I then get the probability that that point came from BC. Okay. So ultimately what you do here when you're talking about lengths is that you're going to figure out what segment do they want the point to come from, and I divide that by the entire overall possible length that it could have come from. And we'll see here a generic question, and then we'll add a little bit of context to it to see how this is actually used maybe in the real world. All right, so when we're looking at this question here, it says point K on ST is chosen at random. What is the probability that K lies on QR? The way I would write this is I'd say P, and then